Just making sure technology's working. If you're with us, we'll get started in just a second. Took it a long time to load, so I'm making sure everything's working. All right, I show 3 o'clock, so we are going to get started. It looks like we have several people with us. If you would like to drop your name in the comments so we'll know you're here, and let me know if you're seeing and hearing everything correctly. I'm Dr. Christy Mulkey, and I'm the workshop coordinator for 240 Tutoring, and I am live in our Facebook groups every Tuesday, so you can find me right here in the TExES Facebook group every Tuesday at 3 o'clock Central Standard Time, and providing you some resources and help to help you prepare for your exam. So today we are going to take a look at the math portion of the EC through 6, and we're going to look at competencies 2 and 3. So stick with me. We're going to jump right in. I'm going to share my screen with you. If at any point along the way you have questions, just drop those in the comments. Now, actually, I'm not sure that's sharing the correct screen, so I'm going to try that one more time. So if you have any questions anywhere along the way, just drop those in the comments. I'm watching those, and I will try to answer those as we proceed. Now, again, we're looking at competencies 2 and 3 because they're so closely related. I wanted to look at them together today. If you missed competency 1, that video is right here in our Facebook group. Just scroll till you find it, or you can also find it on our YouTube channel. So check us out there if you want to take a look at competency 1. Now we're going to look at that competency and the descriptive statements underneath those to help you understand what's expected of you. And then we're going to work through some questions together where we can talk about strategy and the skills you need. And I can provide some explanation as to why the right answer is right and why the wrong answers are wrong. So again, today we're looking at competency 2, which relates to number concepts and operations, and competency 3, which relates to patterns and algebra. So if you read these closely, it says the teacher understands concepts related to numbers, operations, and algorithms, and the properties of numbers. And then competency 3, the teacher understands concepts related to patterns, relations, functions, and algebraic reasoning. Now, if that is kind of foreign to you and too broad, I highly recommend you read all these descriptive statements for both competencies so that you understand exactly what you're going to be tested on. Now, we're going to try some practice questions. Again, if I say anything that's confusing or I lose you, drop me a comment. I'll take a look. So let's start with competency 2. This is question 33 from the preparation manual. So all of these are the free and public questions provided by ETS. For this exam, you can find them at that link I have listed at the bottom here, but I'm going to talk you through those, okay? So this question says, word problem. Samantha's Bakery sells cupcakes in packages of 12 and cookies in packages of 20. The bakery sold the same number of cupcakes and cookies yesterday. What is the minimum number of cupcakes that the bakery could have sold? And then it says, a teacher creates the word problem shown for a math lesson. Based on the word problem, the lesson will most likely cover which of the following math concepts. So we're taking that math knowledge and weaving it into pedagogy, which they do on the TExES test all the time. So the things you need to know here is we're looking for what mathematics concepts, all right? So let's look at what we have here. Least common factor, greatest common factor, least common multiple, greatest common multiple. So the two things you need to know are the difference between factors and multiples. Now, a multiple is a number that can be divided by another number a certain number of times without a remainder. so equally divisible. A factor is one of the two or more numbers that divides a given number without a remainder. Now you're probably thinking, I still don't know what factors and multiples are. So let's talk about this. I like to look at it as factor tree versus skip counting. So if I wanted to know all the factors of the number 18, I'd do a little factor tree. Well, what are two numbers I can multiply together to get 18? Well, I can do 6 and 3. Now I want to keep going till all the factors are prime. So I'm going to break that 6 down a little bit more. And what are two numbers I can multiply together to get 6? 2 and 3. So I now have all this down to prime numbers. So my factors are listed there. These are all factors. So if we did least common factor, we'd be looking at these down here. If we did greatest common factor, it'd be a larger number. Okay, so we'd be looking for the biggest number that they have in common. Now, a multiple is when we skip count or when we multiply. So let's take the number 15. If I wanted to know all the multiples of 15, I'd skip count by 15. 15, then I have 30, then I'd have 45, and then I'd have 60, and so on and so on. So we'd be looking at 15 times 1, 15 times 2, 15 times 3, 15 times 4. So that's how I like to look at it. Factors, I think of factor trees. Multiples, I think of skip counting by that same number. All right, so let's look at this. The bakery sells packages of cupcakes, and there are 12 in each one, and cookies, 20 in each one of those. So if we sold the same number of cupcakes and cookies, what is the minimum number of cupcakes that the bakery could have sold? All right, so cupcakes and cookies. What we would have to do to solve this problem is find a multiple, not a factor, because we're not going to break this down into a smaller number. So that rules out answer choice A and B. We're not looking at factors, we're looking at multiples. So if we were actually going to solve this problem, I would just list all the multiples, 12 and 20. So I'd skip count 12, 24, 36, 48, 60, 72, and so forth. And then I'd do 20, 20, 40, 40, 60. I'm at the end of the day and my pen has decided it's had enough. 60, 80, 100, and I could keep going. But it said, what's the minimum number of cupcakes? So our common multiple here is 60. That would be our answer. So we're looking for that least common multiple. And if you know a few things about math, greatest common multiple, well, that could go on forever and ever and ever. That's not really a thing. So C is the correct answer here. So really, this question is about knowing factors versus multiples. All right, and how you would teach that. Let's look at number 36. So we're looking at operations in real-world situations. It says, this is still competency 2. Celeste is buying erasers for 8 of her friends. There are 76 erasers left at the store. Which of the following approaches can Celeste use to determine the greatest number of erasers she can buy to give each of her friends the same number without having any remaining? All right, and have none remaining. So this question is tricky. I've worked with students on this question before, and you just get so bogged down in all the reading. So she's looking at the store, there are 76 erasers. So just picture them all sitting on a shelf, 76 erasers. And she wants to buy as many as possible. So how many can I buy? So we're looking for the number of erasers she can buy to give to her 8 friends down here equally and not have any left over. All right. Now, most of you are thinking this is a division problem. It's a division. You're right. It is. Okay. But now we start reading these answer choices. A, drawing a picture of 76 erasers and circling groups of 8, counting the number of groups created. You're like, no, that sounds doable. B, creating a table in which one column represents the number of erasers at the store and the other represents the number of erasers each friend receives. So we'd be looking at how many erasers did she get, he get, so forth and so forth. But this is asking for how many did she buy. All right, how many erasers did she buy? Not how many each person could get. All right, this one, probably not. Using a standard algorithm learned previously in class to solve 76 divided by 8. And some of you are thinking, well, that's exactly how you do this. You divide 76 by 8. All right, so you're thinking, maybe. Making an organized list of multiples of 8 to see which one is the closest to 76. Now, when I would work with students, they'd look at me and go, you can do all of these. All of these are correct. Common mistake. Common mistake. This seems way harder than it actually is, because most of you would quickly do 76 divided by 8. Well, 8 times 9 gets me pretty close. All right, standard algorithm. That's what most of you would do. And you're like, well, if they each got 9, there would be 4 left over. Well, right here's your actual answer. The most she could buy would be 72. Because if we're going to divide them up among 8 people equally, the most she could buy would be 72, because any more would leave some left over. So I want you to think about this. This one, we're looking at the number of groups created. That doesn't tell us how many she would buy. It tells us how many each person would get. That's why A is incorrect. Creating a table also tells us the number of erasers each person receives. Using a standard algorithm tells us the number of erasers each person receives. That's what that tells us. The only one that tells us the maximum number of erasers she could buy would be to list out multiples till I got to 76, 8, 16, 24, because I know I've got 8 people, 32. Handwriting gets bad here at the bottom of the slide. All right, and we can keep going. 40, 48, all the way up till we get as close as we can to 76. D is the correct answer. When I would work with students, this was one of the most missed questions. When they would go through the preparation manual, they'd be like, all these answers are right. And it does appear that way. So really what we're looking at here is greatest number of erasers. It kind of goes back to that last question, greatest multiple. Okay, so hopefully that makes a little more sense to you. Let's look at this next question for competency 2. A first grade teacher has set up the following math workstations for students to work in pairs. So again, we got content woven into pedagogy. Station 1, students toss 7 two-color counters from a cup. If you don't know what a two-color counter is, it's a little red dot that's one color on one side and a second color on the other side. They're usually red and yellow in my experience, but I suppose they come in other colors. So they're tossing 7 of those two-color counters from a cup and record the addition equation represented. They repeat this process 10 times. Station 2, each student builds a tower of 8 cubes using 2 different colors and then records the addition equation that the colors represent. Students then exchange towers and record the addition equation for their new towers. Station 3, students are provided with 9 counters each. One student hides some of the counters. The other student looks at how many counters remain present and determines how many are hidden. All right. The students then record the equation that the missing counters represent. Which of the following relationships are students most likely exploring in these stations? So we're looking for relationships. So we want to know, what do all these stations have in common? All right. So that's the quickest way to get through this. I'm going to look for, what do they have in common? Well, in station 1, they're writing addition equations. In station 2, they're writing addition equations. And in station 3, they're writing an equation for something missing. So really what we're looking at here is an addition equation. Here we're looking at an addition equation where they actually know these numbers and they're looking for this one. And here it's a missing add-end equation. So we know the total, we know the sum, and we know one of the add-ins, but we don't know how many were hidden. Now, some of you are like, I don't see addition equations listed as any answer choice. So let's look at this. Guys, an addition equation is a part-whole relationship. So I've got the whole as the sum. There's your whole. All right. And your add-ins are the parts. Add-ins are your parts. So part, whole. All right. Now, if you couldn't get there, let me help you. Spatial concepts will usually have to do with geometry, occasionally measurement, but that's not related to equations. Hopefully you saw equation. One more, one less. If you don't know what this means, it's helping kids solve basic facts faster. So if I know 6 plus 6 is 12, well, 6 plus 7 is one more. So one more than 12 would be 13. So once kids know like their doubles, they can do one more, one less. Or once they know some benchmark addition or subtraction facts, one more, one less. So that's not what we're doing here. Benchmark numbers are looking at 5s and 10s to make the math easier and mental math easier. That's not what we're doing here. So hopefully, if nothing else, you can realize equation, part, whole. That sounds like an equation D. So that's the correct answer there. All right, just checking for comments if you see me looking to the side. Now, there were only 3 questions for Competency 2 in the preparation manual. So I pulled some of ours from our 240 tutoring materials and tweaked them a little bit so that you can get a little more practice with just the math. So let's look at this one. We're still under Competency 2, and we're going to talk about percentages. It says the varsity baseball team has 3 freshmen, 5 sophomores, 3 juniors, and 4 seniors. Approximately what percentage of the baseball team is comprised of sophomores? Now, guys, a percent is the relationship between a share and the whole. So we can set it up like a ratio. So the share and the whole. In this case, the share, it's asking us for sophomores, and there were 5 sophomores. I don't know what just happened there. Let me just try that again. 5 sophomores. And then we've got to figure out the whole. Well, how many people are on the baseball team? We just add these numbers up. Now, you don't have a calculator, so you can either write this out or you can do it mentally. 3, 5, 3, and 4. I try to make 10s when I add because it just makes it easy. So I see 3 and 3 is 6, plus 4 would be 10, plus 5 would be 15. All right. So we're looking at 5/15. Now, how to change that into a percentage? This line in a ratio, or in a lot of cases, stands for divide. So we just divide 5 by 15. Now, if you don't know that one, you could reduce this fraction to make the math a little bit easier. So we could do our division this way, or we could reduce 5/15 to 1/3. As soon as I reduce that, some of you see the answer. And then I could divide 1 by 3. That also works, okay? And that's a little bit easier math. 3 times 3 would get me pretty close to 10. 3 times 3 is 9. Minus 10 minus 9 is 1. I could bring down a 0, and you can see what's going to happen here. 10 divided by 3 is 3. 3 times 3 is 9. It would just keep going over and over and over and over and over. If you do the division this way, you're looking at 0.3333 and so on. All right. That would move that decimal over 2 places because a percentage is looking at out of hundredths. Okay. Move that decimal over 2 places and 33%. It's a good thing to memorize, if you don't already, that 25%, there are 4 quarters in a dollar. 4 25s is about the same as a fourth, or it is the same as a fourth. 20, 20, 40, 60, 80, 100, 1/5. 33% is pretty close to 1/3. 32%, well, that's just odd, okay? So if you can memorize those benchmark numbers when we're looking at percentages, that will help you move through this a little bit faster. Let's do another one in competency 2. This one is looking at fractions. So we're going to look at these fractions. Put the following fractions in order from greatest to least. So I'm going to note greatest to least so I don't forget, because our natural tendency is to do least to greatest. So they love to trick you and throw in greatest to least because we like to do least to greatest. Now, we can't order these fractions because their denominators are different. So we're going to have to find a common denominator, all right? You can't just line them up by the digits you see here, okay? So we're gonna have to find a common denominator. So I'm gonna start with my largest denominator I see here and see if that works for everyone. So 10, 2 times something is 10, yes. 5 will go into 10, 4 will not. So let's do a multiple of 10. Let's go to the next multiple, 20. 2 will go into 20, 5 will go into 20, 4 will go into 20. So we can set up our least common denominator as 20. You didn't know all this math was going to connect together today, did you? All right, so we're going to trade these all into 20ths. So 2 times what would be 20? Times 10. So 1 times 10, 10 20ths. 10 times 2 would be 20. So if we multiply by 2 down here, we multiply by 2 up here. 7 times 2 is 14 20ths. Same principle. 5 times 4 is 20. So if we multiply by 4 up here. 4 times 4 is 16. 4 times 5 is 20. If we multiply by 5 down here, multiply by 5 up here. So now we have 15 20ths. Now I'm going to label these. My greatest fraction is right here. Number 1, 16 20ths. Now I can compare them. And then I have 2 would be 15 20ths. 3 would be 14 20ths. And the least would be 10 20ths. So I know first in my list, I'm looking for 4/5. Well, right there, D is the only one that has 4/5 first. I can quickly check. 3/4 should be second, 7/10. Now I want to point out some things to you. Notice if you didn't read this carefully and did least to greatest, that answer choice is there. That answer choice is there. So be careful if it says greatest to least that you put them in order from greatest to least. If you just try to look at these denominators, that answer is also there. So got to know that you've got to get a common denominator. Now, let's look at competency 3. This is probably the hardest question we're going to do today, and I'll end with an easy one, I promise. But competency 3 here, we're looking at algebra, fun stuff. We've got a chart that shows time and a temperature recorded at each of those times. And it says a cold front arrived at 12:05 a.m. and the subsequent temperatures were recorded in the table shown. If X represents the number of hours after 12:05 a.m., which of the following equations best represents the change in temperature as a function of the time? So really, the math behind this, if we had a math person, if I put my math teacher hat on, I would talk to you about functions, and I would talk to you about slope, and I would talk to you about rise over run and rate of change and all of that fun stuff to solve this. But a lot of you, if you're watching this video, it's because those things are hard for you and you're wanting some help. So I want to show you that if you understand how that works, if you understand functions and slope, by all means do that math. You'll quickly see the answer, okay? If you don't understand those things, I want to show you, you can still solve this problem without knowing anything about slope, all right? So I'm just gonna mark a few things for you, all right? It says if X represents the number of hours after 12:05. So this line right here, this top row is our X, and it says we're looking for the temperature change, okay? So that would be Y down here, okay? Now I'm just gonna note the changes. From here to here is 2 hours. From here to here is 2 hours. From here to here, oh, it changed, 1 hour. And from here to here, 1 hour. Bear with me so far. okay? It's a tough problem, especially if you don't know slope and functions. I'm gonna show you, you can totally do this. Now I'm gonna mark the change that occurs down here. 67 to 60 would be minus 7. 60 to 53 would be minus 7. Watch what happens here. 53 to 49.5 is minus 3.5, and 49.5 to 46 is minus 3.5. I wonder if any of you are seeing it yet. We have a relationship here, all right? 2 hours was 7 degree drop. 1 hour was 3.5. Anybody done the math in their head yet? All right, if I double 1, I get 2. If I double 3.5, what do I get? 7. Okay, so let's look at this equation. So if we want to know y, all right, how much is the temperature changing? Okay, we know x is the hours. So we've got to put a number in here with x plus or minus, however you want to look at it. We've got a whole bunch of pluses over here, 67. All right, now I looked at this the other direction, okay? So a lot of people set it up this way, and even when I did, I was like, yep, I'm going to reverse it. Okay, so I started with 67, and I said that temperature went down 7 degrees. All right, so the temperature change, that would be y. The problem is I'm looking for an equation that fits this entire table, all right? So that's not going to be true every time. I can't take that temperature minus 7 and get the temperature change, all right? So I'm going to have to set this up as 67, all right, everybody with me, minus 3.5x, where x equals hours, So if it's 1 hour, yeah, it went down 3.5. But if it's, because 3.5 times 1 would still be 3.5. If it was 2 hours in between, it would be 3.5 times 2. Okay, so everybody with me? And then that equals y. All right, and then I can just reverse this equation. You ready? So y equals negative, because it's going down, 3.5x plus 67. Correct answer here is D. Correct answer here is D. Now, that is the way you solve this without knowing anything about functions or slope or any of that business. It's just analyzing the numbers that are given to you here. Once I labeled this chart, things should have started clicking for you. Things should have started clicking. Because if we plug a 2 in here for the 2 hours or a 1 in here, you could actually solve these and figure out which ones work and which ones don't. All right. But I just reasoned my way through it without any coordinate plane and looking at slope and all. Well, the slope would actually go in the other direction, but looking at any of that. So if you don't understand functions and slopes, or it's really hard for you, don't be afraid to just tackle it. Look at the data that you're given and try to work through it. You would be surprised how many times you can actually arrive at that correct answer. We've got some comments. I'm just going to check on that real quick and make sure. And sorry, you can hear me. Nothing that I need to answer. So thank you for the positive feedback, guys. I do appreciate it. We're going to move on to our last question today. And this is on Competency 3. And again, there was only one question in the preparation manual on Competency 3, and it was a doozy, that's for sure. But I wanted to show you there can be easier questions for Competency 3. So here's one from our 240 tutoring materials that I've tweaked just a little bit. It says, which expression can be used to solve the following word problem? Mrs. Dunlap has planned a field trip for 3rd grade students. They have 2 buses and 49 people that need rides. There are also 2 coolers that will carry lunches that need to be stored on the bus. On the morning of the field trip, 3 students are absent. How many people will be on each bus? So I'm just going to draw a quick sketch. I have a whole bunch of people up here. These are all my little 3rd graders, okay? ... There are 49 of them, and I've got to get them on 3 buses, or on 2 buses, sorry. I got to put these kids on these 2 buses. Most of you see division. All right, easy enough. Some of you might have gotten hung up on the 2 coolers. Guys, that's extra information. But there's one extra step here. It says, on the morning of the field trip, 3 students were absent. So I've got to remove those 3 students first. So 49 minus 3. Then I can split them up onto the 2 buses. So that subtraction would have to occur before the division. All right, that would occur before the division. So 49 minus 3 divided by our 2 buses. So much easier sample of competency 3. So don't let competency 3 completely scare you. You might find some simpler ones. All right, I'm running out of time. So I want to remind you there's no calculator on your test. So here's what I recommend. If you're struggling with basic facts, if I was doing some addition and subtraction and division and multiplication, you're like, I need my fingers, or I need scratch paper to write that out. I highly suggest a good little practice thing when you're bored is just get on your phone, download an app that has basic math fact practice, addition, subtraction, multiplication, division, and just get faster at those. Because one of the most common reasons I had students tell me they failed the math portion of the test was, y'all know the answer to this question. I ran out of time. So the quicker you can get at that basic math, the better off you will be. So practice those basic math facts because you don't have a calculator to just put in the numbers. So know those things. Know the style of questions, how many questions, know what the screen looks like. Do some practice like I have right here at this website, and practice your pacing. Don't just do questions, but actually practice doing them quickly, all right? Last but not least, if you need more information, I highly suggest you check out our study guides at 240tutoring.com/study guides. And then we have free resources right here at 240tutoring.com/resources. These videos, I will be here every Tuesday for a live video at 3 o'clock Central Standard Time, and they're saved here. So if you want to go back and watch them at a later time, you can. If you're watching this later and you have a question, please drop that in the comments. On Wednesdays, I do what we call office hours, where I just spend time in the Facebook group trying to answer as many questions as possible. So if you're watching this later and you have a question, put it in there. It'll pop up to the top of the Facebook group, and I will try to answer those on Wednesdays. We're also putting these videos on our YouTube channel, so if you're more of a YouTube person, you can check us out there. I hope you found this helpful. Next week, we'll tackle some more, and I hope to see you there. Again, I'm Dr. Christy Mulkey with 240 Tutoring. I'm going to check this last comment and make sure it wasn't someone who needed an answer. So if you're more of a YouTube person, all right. No, thank you guys. I'm so glad I can help you. So I appreciate the feedback. I will see you next week.